Hi, welcome to my lab 4 video. In this week's lab, we're going to analyze a free object which is dropped from a height and freely oscillate. We are going to analyze the energy principle and the series underneath it. So here are the contents in my video. These are some useful formulas we need to know beforehand. On the left side, we have the Newton's second law, which are the contents we learned from the beginning of this semester. And at the left is energy principle. The total energy is equal to the potential energy and the potential energy in the string and the kinetic energy. And at the end of this video, we will know the total change of the energy will be 0 because it's a closed system. And these are three formulas for calculating the kinetic energy and the potential strings potential energy and the gravitational potential energy. And now let's take a look at my tracker video. You can see I used a graph to track the trajectory of the object. And now we need to calculate our stiffness constant. By using this formula, we will know our stiffness constant will be around 6.92, and our original string length is 0.109. And let's take a look at my code. So I added the Ball's mass and the initial position vector. Here I just changed the constant as I mentioned before, and these are the formulas I mentioned in the second PowerPoint. And here I changed the time period to 9.972 because it's the length of option 1 video. And here L is equal to the changing in spring length. And basically, if we putting all the formulas, we will get our final model. And let's take a look at our results. So here you can see my predicted model is moving along with my experiment result. So you can see it's moving like a circle, oscillating like a circle. And from this, we can conclude that here's my resulted graph. And from this graph, we can know that our total, the orange line is the delta E, which is changing energy, which is equal to 0. So for our follow-up question 1, we will know that there is no energy change for the total system. And now let's take a look at our trackers X and Y axis. Like you can see that from it's a little bit different from between my predict model and the experiment one. That is due to the loss in the thermal energy and some drag force in the string. And due to that, we can see there's a little bit difference between the X, as there's a lag off between the experiment 1 and the model XY axis. And here for the follow-up question 2, for single acceleration in the tracker X, for single acceleration is just this curve. So X is 1.994 and Y is 1.889. And that's it. Thank you.